Hey guys, happy first day of notes. So today we are going to start with chapter 1, section 4, solving equations. But before we get into the notes, we are going to start with this do now problem. The do now problem is going to get us ready for this section. So if you would like to pause the video now and try this problem on your own, you can. Otherwise, let's get started. So you bought a mobile kit. You read on the package that the weight of the entire mobile is 40 ounces. Each inch of crossbar weighs 1 ounce. What is the weight of each shape? So we have a mobile, and this mobile has one support in the middle. Obviously, both sides of our mobile look perfectly balanced because our crossbar is straight. So if the whole mobile is 40 ounces, then we know that the right side of this mobile and the left side of this mobile have to each be 20 ounces. So our weight has to be evenly distributed. So each side is 20 ounces. Let's look at our left side first because we only have one shape to figure out there. So we have 20 ounces for this side, but our crossbar is 4 inches long. And it told us in the problem that each inch is 1 ounce. So if it's 4 inches, that means that this bar is a total of 4 ounces. So if the bar is 4 ounces and the total side is 20 ounces, that means that our orange shape on this side has to be 16 ounces. Now on the right side, we have a 4-inch crossbar again, so that's 4 ounces. And then the rest of our mobile, we are left with 16 ounces to distribute. So after that support bar, we have another support bar. Each side is 2 inches, and each side of our mobile there is evenly distributed in weight as well. So each side is 2 inches. So we have 2 ounces and 2 ounces again. After that support bar, then we are left with 12 ounces for the remaining piece of our mobile. So we have 12 ounces. That means that each side is split into evenly distributed. It's 6 ounces and 6 ounces, which means that this yellow shape here must be 6 ounces. So now looking at the last piece of our mobile with our green shapes, our crossbar is 1 inch and 1 inch, so that's 1 ounce and 1 ounce. If the entire thing is 6 ounces and the weight is evenly distributed, that means each side has to be 3 ounces. So our green shapes, because we have 1 ounce for the crossbar, our green shapes are left with 2 ounces and 2 ounces. So breaking this up evenly and thinking about the weight distribution, you're able to figure out the weights of all the crossbars and the weights of all of the shapes. So let's get started on the notes. So solving an equation that contains a variable means finding all values of the variable that make the equation true. Such value is the solution of the equation. So usually when we're solving equations, we will be trying to isolate a variable and figure out what number or numbers make that equation true. To find a solution, you isolate the variable on one side of the equation using inverse operations. And I know you all know what our inverse operations are. Our examples, we have addition and subtraction, multiplication and division, and square root. So these operations are going to cancel each other out. So as we're moving variables and numbers around our problem, we're going to have to use inverse operations to cancel them out. So our first example, and throughout these notes, throughout the video, I encourage you to pause the video and try examples on your own, and then you can always play it and double check that you got everything right. So what is the solution of x plus 45 equals 40? Our unknown in this case is the variable x, so we need to isolate that on one side of our equal sign. So that means that we need to get rid of this plus 45 here. Opposite of plus 45 is minus 45, so we're going to subtract 45 from both sides of the equal sign. Remember, when we're talking about equations, we need to make sure that we're not changing anything, changing the actual value of the equation. So whatever we do to the left side of our equation, we have to also do to the right side. So when we solve here, 45 minus 45 cancels out, and we're left with x equals -5 for the value of this solution. You can always plug this back in to double check. So we plug back into our original equation. X plus 45 equals 40. X is -5, so -5 plus 45 equals 40. -5 plus 45 is 40, which equals 40, so we're good. We plugged it back in, and it is true. Next example. Today we're going to be doing a lot of examples. So solve the following problem. There are a couple different ways that we can solve this problem, but let's start with distribution. So if we distribute this 2 into our parentheses, that means we're multiplying 2 by each term in our parentheses. So when we multiply, 2 times x is 2x, 2 times -8 is -16, which equals 20. So now we have gotten rid of these parentheses, and we have a variable that we want to isolate. We want to isolate this 2x. So we need to get rid of -16. Opposite of -16 is +16 to both sides of our equal sign. These cancel out. Now we have 2x equals 36. Last step to get x by itself, we need to divide both sides by 2. And we get x is equal to 18. Again, for these problems, you can always plug back in once you have a solution to double check that you did this correctly. Next example, we have the same problem. So now we're going to solve the following problem just using a different method than what we did before. So in our last problem, we used distribution to start to solve this problem. But notice this 2 is being multiplied by everything inside of our parentheses. So we have 2 times x minus 8. Because the right side of our equation is divisible by 2, we are able to start by dividing both sides by 2 rather than distributing. If all of your terms are divisible by 2, I would recommend you doing this because dividing are going to make your numbers smaller, multiplying is going to make your numbers bigger, which in some cases is going to make the problem more difficult. So these 2's cancel out, and we're left with x minus 8 equals 10. Last step to isolate x, we're going to add 8 to both sides. These cancel out, and we're left with x equals 18. So we got the same answer both times. Dividing first made it a little bit easier, so if you can, try to divide first. If not, you will get the same answer either way. Next, solve the following problem. After you are done, think of another way to solve the problem. So looking at this problem, we have -27 plus 6y equals 3 times y minus 3. So we have parentheses. We want to try and get rid of those parentheses. We can distribute. But if we think about what we just did in the last problem, if all of our terms are divisible by 3, which they are, we have 3, 6y, and -27, it'll be easier if we divide everything by 3 first. When we divide everything by 3, we have -9 plus 2y equals y minus 3. So we've gotten rid of those parentheses without having to distribute. And now our numbers are just a little bit easier to work with. So -9 plus 2y equals y minus 3. We want to isolate our variable, which is y. We need to get it to the same side of the equal sign. So we're going to move y to the other side by subtracting y from both sides. And we need to move our constant. So -9, we add 9 to cancel those out. 2y minus y gives us y equals +6 for our solution. Our next example. Solve the following equation and check your solution. So we have 11 plus 3x minus 7 equals 6x plus 5 minus 3x. So on the left side of our equation, we have two terms that are constants, so we are able to combine like terms before we move anything to the opposite side of the equal sign. When we combine like terms, we have 3x plus 4 equals. On the right side of our equation, we also have like terms, 6x and -3x. When we combine like terms, we have 3x plus 5. Now we need to move our variable to the same side of the equal sign, so we're going to subtract 3x from both sides. When we subtract 3x, notice 3x minus 3x and 3x minus 3x cancel out all of our variables. So we're left with 4 equals 5. So now our variable's gone. 4 equals 5 is not a true statement. 4 is never equal to 5. This is a false statement which means that this equation has no solution. This symbol here represents no solution, so you can draw that symbol, or you can just write out no solution. There is no value that we are able to plug into x for this equation to make both sides of our equal sign equal to each other. Next example. Take a second, you can pause this video and try this one on your own. So let's get started. On the right side of our equal sign, we have a few like terms that we are able to combine. So let's do that first. So we have 8 times x plus 1 equals 19x minus 11x gives us 8x. 10 minus 9 is positive 1. So now notice not all of our terms are divisible by 8, so we're going to have to distribute this 8 into the parentheses to get rid of it. So now we have 8x plus 8 equals 8x plus 1. We're going to move our variables to the same side, so subtract 8x from both sides. When we do that, all of our variables cancel out, and we're left with 8 is equal to 1. Similar to the last problem, we know that 8 is not equal to 1. That means that this equation has no solution. There's no value that you can plug in for x to make this equation true. So like we just saw in the last couple of examples, an equation does not always have one solution. An equation has no solution if no value of the variable makes the equation true. Like we just saw in those last examples, if you get something like 5 is equal to 4, that is never true, so there is no solution. An equation that is true for every value of the variable is an identity. So some equations can have some solutions, always have a solution, or never have a solution. If it is an identity, like 0 is equal to 0, that is always true. So any value that you plug in for x is going to make your equation true. Now let's look at some examples. Is the equation always, sometimes, or never true? So our first problem, we have 7x plus 6 minus 4x equals 12 plus 3x minus 8. We have some like terms on the right and the left side that we can combine. When we combine like terms, we're left with 3x plus 6 equals 4 plus 3x. Solving further, to get rid of our variables, we're going to subtract 3x from both sides. When we subtract 3x from both sides, everything cancels out and we're left with 6 equals 4. We know 6 is never equal to 4, so this equation is never true. There's no solution. There's no value that you can plug in for x that makes this equation true. For b, we have 2x plus 3 times x minus 4 equals 2 times 2x minus 6 plus x. So we have two sets of parentheses. We can't divide right away to get rid of anything, so we're going to distribute. When we distribute, we have 2x plus 3x minus 12 equals 4x minus 12 plus x. On our right and our left sides, we have like terms that we can combine. So when we combine like terms, we have 5x minus 12 equals 5x minus 12. Notice our expressions are exactly the same on both sides of our equal sign, but let's solve further to make sure. So now we're going to move our variables to the left, so we subtract 5x from both sides and add 12 to both sides. When we do that, when we use our inverse operations, every single term cancels out, which leaves us with 0 is equal to 0, which is our identity. So this equation is always true. No matter what number you plug in for x, this equation is always going to be true. Our next example, let's look at a word problem. So creating an equation to solve a problem. I'll give you a second to copy this problem down. You can pause the video if you need extra time. So, flowers. Flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Palace in Brussels, Belgium, has a perimeter of 200 meters. What are the dimensions of the flower carpet? So we're given a couple things. From this diagram, we're shown two values. We're shown that the width of this flower carpet is represented by the variable x. We're also shown that the length of this carpet is represented by 3x. So that's what we know looking at the diagram. We also know from reading the problem that the perimeter of this carpet is 200 meters. So we're talking about perimeter, we need the equation for perimeter. Perimeter is equal to 2 times the length plus 2 times the width. And we know from the problem that P is equal to 200 meters. So first, write out all the information that you can take from the problem and then see where you can plug in. So now we know that our P variable is equal to 200 meters. We know that L is equal to 3x, and we know that W is equal to x. So let's plug in and see what we can do. When we plug in, I'm going to plug in on the next slide so that we have some room. So we have perimeter is equal to 2 times the length plus 2 times the width. We know that the width is represented by x, the length is represented by 3x, and our perimeter is equal to 200 meters. So now we're just going to plug in all of our values for the variables. Our perimeter is 200 meters. That's equal to 2 times the length, which is 3x, plus 2 times the width, which is x. So all I did here was plug in for all of my variables. Now I have an equation with one variable, which is x, and we can solve this. So when we solve, we have 200 equals 2 times 3x gives us 6x, plus 2 times x is 2x. On the right side of our equation, we can combine like terms. So 200 is equal to 8x. To isolate x and solve this equation, we're going to divide both sides by 8. When we divide, we get x is equal to 25. So now we've solved for our variable, but we're not trying to solve for x here. It says what are the dimensions of the flower carpet. So after we find x, then we have to plug back in to figure out our width and our length. So if x is 25, that means that the width is going to be equal to 25 meters. The length is 3 times the width, which is 3 times 25 meters, so our length is going to be 75 meters. So when you're solving a problem solving a word problem with an equation, start by picking out all the information that the problem tells you, and then see if you can plug those variables back into your equation. Next, we are going to talk about literal equations. A literal equation is an equation that uses at least 2 different letters as variables. You can solve a literal equation for any one of its variables using the properties of equality. You can solve for a variable in terms of the other variables. So you saw a couple of examples like this on your summer packet. When we have equations with more than one variable, we can solve in terms of, which is just going to isolate one of our variables. So let's look at some examples. Our first example, well, just looking at this example, we're not solving it. The equation C equals 5 over 9 times F minus 32 relates what? Take a second and think. What variables do you know for C and F that are related to each other? Did you get it? C represents Celsius, while F represents Fahrenheit. So these variables are talking about temperature in degrees. This equation can be very helpful because here we talk about degrees Fahrenheit, while in most other parts of the world they talk about degrees in Celsius. So this equation will transfer from degrees Celsius to degrees Fahrenheit. But what is F in terms of C? So this equation is given to us that C equals 5 over 9 times F minus 32. So we have it solved for C right now, but we want to figure out what F is in terms of C. So what is F tells us that we want to solve for F. So our equation right now is C equals 5 over 9 times F minus 32. f minus 32 right now we have in parentheses, and our fraction 5/9 is out front. We do not want to distribute this fraction because that's going to make more work for us. So rather than distributing, we're going to get rid of this fraction by multiplying by the reciprocal. So we're multiplying both sides by 9/5. When we do that, we get 9/5c equals f minus 32. And now, simple, straightforward, to isolate f, we're going to add 32 to both sides. And when we do that, we get 9/5c plus 32 is equal to f. So f in terms of c, f equals 9/5c plus 32. And we're done. Normally, whatever variable you have isolated, you want to try and get to the left side just to make it look nicer. So when you solve, you can always just flip it around to make your variable on the left side. Let's look at another literal equation example. Solve the formula for the indicated variable. So we have r times r1 plus r2 equals r1 times r2, and we're solving for capital R. So capital R right now is almost isolated. It's just being multiplied by our parentheses, which is r1 plus r2. So it's being multiplied by our parentheses. Opposite of multiplication to get rid of this is going to be division. So we're going to divide both sides by r1 plus r2. When we divide, now we have r isolated, so r is equal to r1 times r2 over r1 plus r2, and that's it. This one was a simple one step. Our next example. Take a second, pause this video and try this one on your own. We have h equals v times t minus 5t squared, and we are solving for v. So we want to isolate this v in our equation. To isolate the v, first thing that we can get rid of is 5t squared. So right now we have minus 5t squared. Opposite operation is going to be plus 5t squared. So we're adding 5t squared to both sides of our equation. When we do that, we're left with h plus 5t squared is equal to v times t. Now we just have to do one more thing to get v by itself. We have v times t, so we're going to divide both sides by t. And we're left with h plus 5t squared divided by t is equal to v. So in terms of v, this equation is going to be v equals h plus 5t squared all over t. A couple more examples. Solve the formula for the indicated variable. We have q equals 3a plus 5 times a times c, and we're solving for a. Now this one's a little bit different because we have two terms with a, but they're not like terms, so you can't add them together. We can only combine like terms. So if we can't combine like terms, we need to take this a out of these two terms, which means that we're going to factor it out. If we factor a out, we have q equals a times 3 plus 5c. And you can always double check by distributing this a back into these two terms to make sure we get back to the same expression that we started with. So when we factor a out, now we have a times 3 plus 5c. Now this is very simple, opposite of multiplication. We are going to divide both sides by 3 plus 5c. When we divide, we're left with q over 3 plus 5c is equal to a. So our equation in terms of a equals q over 3 plus 5c. Our last example for this section. So we've solved the formula for the indicated variable. 3a times x over 5 minus 4c equals ax over 5, and we're solving for x. So in this Google Slides, sometimes your fractions look a little crazy because it's not exactly set up for math problems. So I'm going to rewrite this problem here. So we have 3ax over 5 minus 4c equals ax over 5. So the first thing we want to do, we want to get our x values. We're solving for x. We want to get x to the same side of the equation. So we're going to subtract 3ax over 5 from both sides. When we do that, we're left with negative 4c. And on this right side, we have ax over 5 minus 3ax over 5. You'll notice these fractions are actually set up perfectly. The denominators, they have a common denominator, and in our numerator, we have like terms. So we can just combine like terms here. So ax minus 3ax is going to give us negative 2ax over 5. If we had a different denominator, you'd have to multiply to form a common denominator. So now we only have one x variable. We need to isolate that x. So we have negative 2 over 5, negative 2ax over 5. To get rid of some of these terms, we're going to multiply by the reciprocal. Multiplying by the reciprocal, but leaving this x here. So the reciprocal is going to be negative 5 over 2a. So we're multiplying both sides by negative 5 over 2a. When we do that, everything on the left except for x cancels out. And on the right, we are left with negative 5 times negative 4c is positive 20c over 2a equals x. Almost there, but notice in our numerator and our denominator, we have a common factor, which is 2, so we can simplify a little bit further, and x is going to be equal to 10c over a after we divide everything by 2. So our final answer for x equals 10c over a. So when you're doing these problems, just focus on your variable, get all the variable that you want to solve for to the same side of the equal sign and isolate it. And when you're finished with your problem, always write your variable on the left side to make it look a little bit better. Okay, so that is it for section 4, solving equations. Your homework for tonight is page 30 to 31, 22, 23, 24, 28, 30, 31, 34, 49, 55, and 60. This homework you can complete in a notebook. You are going to take turn that into a PDF using the app that you used for the summer assignment and upload it to the assignment on Google Classroom. As always, if you have any questions, feel free to email me. I will be on Google Meet the entire class, so pop back into the Meet and ask any questions. Good luck.